In this video, I want to show you how you can use Microsoft Excel to solve transportation problem. Transportation problem. So, transportation problem is a special type of linear programming problems, and the objective is to ship some equipment or some goods, or you want to transport some commodities from sources 1, 2, 3 to destination 1, 2, 3, 4. This 1, 2, 3 beside its source is just a label for the branches or the origin. So you can call this S1, S2, S3. And you want to ship those equipment or those goods to destination D1, D2, D3, D4. Okay. And for the first source one, the supply capacity is 5. For the source or origin number 2, the supply capacity is 2. Okay. And for the source number 3, the supply capacity is 3. So I can actually repeat this table here. I can repeat the problem here and have a S1, S2, that's the source. I don't want to use numbers. S3, okay. And on the table, I will use D1, D2, D3, D4. That will represent a 1, 2, 3, 4 under this destination, and the 1, 2, 3 here. So this is the source and destination. Now let me repeat the numbers here. 3, 7, 6, 4. Okay. And I have 2, 5. You have 2, 4. Just to copy that. 3. You have 8 and 3. So these numbers here, these numbers, they just the unit costs, unit shipping costs per location. Okay, all right. Let me make this bold. B. And let me make the source bold. All right. So now this is the problem here. Remember, this is an image. I'm just repeating it over here. So these numbers 3, 7, 6, 4, 2, 4, 3, 2, 4, 3, 8, 5. They each of them represent the unit costs, shipping cost per location. In other words, to move any goods from source 1 to destination 1, that will cost you maybe $3. To move from source 3 to destination 4, that will cost you $5. So these numbers, let me make this B centralized. Okay, alignment center. Okay, I'll do the same thing for the source. Is our 1, 2, 3 over there. So the source is also center. I'll do the same thing for numbers, the entry. Okay. Send. So that is the problem originally, but you also have a supply, supply, under supply. For each row, for each source, you see, source number one, the supply capacity is 5. For source number two, the supply capacity is 2, as you can see right here. For source number three, the supply capacity is 3. Okay, that's fine. And I also have a demand. I need to make a demand. So there is a demand from destination one, okay, or customer one. This can be customer one, customer two, customer three, customer four. There is a demand. The demand uh, by destination one or customer one is actually 3. As you can see here, 3322. For destination 2, the demand is what? 3. For destination 3, demand is 2. And for destination 4, demand is 2 also. Okay, now this is a complete data set for transportation problem. If you add up the number for demand, you add up this demand by destination 1 is 3, demand by destination 2 is 3. If you add up all the total demands, that will give you 10. 3 plus 3 plus 2 will give you 10. Fine. If you come under supply, if you add up all the supply numbers, 5 plus 2 plus 3, that will give you 10 also. So the total supply equals to total demand. That is a balanced equation. Then you can have a visible solution. Okay. Now, for this question, you can say, you can boldly say the decision variables. You see that? Somebody type this. Let me make it blue. Uh, okay. You can boldly say that the decision variables. Okay, let me. Decision variables associated with each of these numbers. Okay, is x11, x12, x13, x14, x21, x22, x23, x24, x31, x32, x33, and x34. You have 12 numbers associated with this 3 by 4 matrix. So these variables are what you are looking for in transportation problem, and they actually represent the number. They represent this x ij represent what? Number of shipments by location. See that? Number of shipments. So you want to see these numbers. They are separate from these numbers. The numbers here, they are just cost. Okay? The numbers here are just quantity. So unit cost, quantities, to have a total, you need to multiply each unit cost by the quantity. So now you can boldly say now that you want to carry out this operation. So the problem is to, you see that? The problem now is to minimize the shipping cost for moving equipment or goods from all these three sources to these four destinations. You want to minimize the shipping cost, and the shipping cost is going to be product of each of these costs, 3 times x11 plus 7 times x12 plus you go all through what this 5 times x34. You add up all of them, and that gives you this this cell. Okay, that is the problem. You want to minimize that, subject to the following constraints. You see that? Take note of that. Subject to the following constraint. You want to make sure the row constraints under row, the total quantities or supply, the total numbers must be equals to 5. For row 2, it must be equals to 2, and for row 3, it must be equals to 3. So you want to have x11. Remember, this is what you have in row 1. Okay, x11 must be equals to 5. You see that? You see that down here? That is called row 1 constraint. Also for row 2, this is your row 2. It must be equals to 2. You see that? Because you have 2 here under row under origin 2 or source 2. And finally, what continuing that way, you have a row 3 constraint to be what? x31 plus x32 plus x33 plus x34 equals to 3. You must have that. Okay. And you also must have constraints for columns. This is the row constraints. As you can see here, row constraints. Can you see that? Row constraints. So you have 3 rows. You have this is the first row, second row, third row. Now, for column constraints, you must have 3 plus 2 plus 4. Okay? Oh no, excuse me. The numbers here is x11 plus x21 plus x31, which is for this column, it must be equals to 3. For the second column here, x12 plus x22 plus x32 must be equals to this 3. You see that? That's the second column here. And x13 plus x23 plus x34 must be equals to 2. That is the third column constraint. And the last constraint is the fourth column, which is x14, x24, x34 must be equals to 2. This is a 2 for column 4. Okay. Once again, don't mistake these numbers here, which are actually the unit cost, unit shipping cost per location. Unit shipping cost per location. Don't confuse that number from the actual quantities that that is to be shipped or that were shipped. So those quantities x1, x12, x13, x14 up until x34, they are called decision variables. And once again, they represent number of shipment per location. Okay, so that is the problem we are solving. See that? You can translate the problem into lingo. This is the lingo. If you run this lingo, it will solve it for you. You have some nice solutions. Okay, yeah. So you have solutions here. These are the solutions for x11, x12, x13 up until x34. Remember, this is what we are trying to do also in Excel. All right, so you have that. Now, How do you solve this problem in Excel? How do you solve it? Remember, what you have here is not part of, it's just an explanation to the problem. All these are just additional notes. Okay. Now, let me have a, let me just make my, let me repeat what I have up there. We have a S1, S, S1, S2, S3. Okay. Uh, yes, for, and B1, B1, B2. I can actually copy that instead of typing from scratch. I can copy all this. I just need to copy all this. I need to copy all this. Copy, move down a little bit. Now I don't need to have these numbers here because those ones are up. You see, yeah, I need to have the supply intact, but this 4 and 3, I mean the one I'm deleting now, must be empty. Okay. It must be empty. This must be given to you. This must be given to you. This will be given. This will be given. This demand by each of the destination must be given to you, and the supply from each of the sources. Source one, the supply is 5. Source two, supply is 2. Source three, supply is 3. What we are actually looking for, we are looking for the values of x11, x12, x13, all these values that must fill this box. Okay, we want to look for automatically compute the values for all these x11, x12, x13, x14. Okay, but we don't have them from the beginning, so we have to delete that. Okay, so that is a special cell for decision variables. Okay, decision variables. Let me just select that region. I need to fill up that space automatically after running the solver. Let me make it orange color. Okay. Let me format the border. Okay, and that. Cool. Okay, I need to fill up those. Also, I need to have a capacity. Okay, capacity. I need to have that section for to compare because the when you solve this problem, Excel may put 0 here, it may put 1 here for you, it may put 2 here for you, and put 2 here. If you observe now, 0 plus 1 plus 2 plus 2 must give you 5. Okay, but you want to do that automatically using the solver. Okay, so this is the sum. Let me call it sum rows. Sum rows. Okay, sum rows. Okay, and let me call this one sum column. Sum columns. Sum columns. Sum rows. All right. So now I need to compute these 4 cells automatically. So let me make it background to be maybe yellow, and also let me make the border to be I also need to compute sum each of the rows. I need to sum them up here. So I need to make that special. Let me give color blue. Okay. And the border. Cool. Then I need my objective function. Objective function, which is this function here. Objective function Z. I need to compute that automatically. So I need to have a background for that too. Let me make it green. Now I'm getting there. Let me just call this place equals just to label it. So when I add up this all the first column, I add up D13 to D14, it must be it must be I add up all element under D1, it must be equals to the first yellow cell here. If I add up D2, column D2, it must be equals to the yellow cell here. If I add up everything in D3, that is this one, the next one, and the third one, it must be equal to the third yellow cell. Lastly, this one plus this must be equal to this. The same thing in the row S1, if I add up the first element, second element, third element, fourth element, in the first row S1, it must be equal to the first blue cell here. And this function here, oh, why is this frozen? Excuse me? Yeah, the minimum, you are minimizing 3x1 plus 7x12 plus 6x13. The objective function should be here. So let me set them up and then solve it. Okay, so here I need to have to sum up all the elements in a row S1 into the first blue cell here. So I'm going to use equals sum, the sum function. Open a parenthesis, select the first cell, move it, get the third one, fourth one, close the bracket, enter. So that will give you 0. You do the same thing for the second blue cell, equals sum. Okay, so come here, first cell, second, third, fourth, close it. Okay, that will give you the second blue cell. And this one is a equals sum, same thing. First one, second one, third one, fourth one, close it. Now you observe that there is nothing inside the orange cells. But when I sum up all the rows, I'm adding 0. That means in Excel, even if you don't type in anything or inside any cell, Excel will assume a value of 0 for each of the cells. That is why you're having, I think the same thing go for the sum, for the column. So for this column, I'm going to add up everything, all the orange cells under D1, D2, D3, D4, and put each of them in this yellow cell. Okay, I'm going to have equals sum at second, third, close it. Okay, equals sum, first one under D2, second one, third one, close it. Okay, and you can actually drag. Let me just and then the third one equals sum, first, second, third, close the braces, move to the fourth one, equals sum, first, second, third, close the bracket. Okay, so our setup, how you can, the reason is because when you solve Excel, for instance, Excel might compute 0, 1 for that, and give you 0 here, and give you 2 here. Okay, when you solve it, if you observe now that 1 plus 0 plus 2 gives me 3 automatically. But to begin with, nothing will be inside that. Okay, so it's 0. It's 0 to begin with. Now, I've done for the row constraints and the column constraints. Okay, then I need to do for objective function. If you look at the objective function here, you are multiplying each of these cells, okay, by each of the orange cell. So you need to have a product between dot product between these cells and that cell. Capture the formula for the objective function here. This objective function here, which is actually each of the quantity sheet multiplied by each of the unit cost. Remember, if you buy an orange for $2, one orange for $2, 10 oranges is going to be what? 10 times $2. That is $20. If you buy one orange for $2, X oranges will be 2X. So that is why you have a 3X1, 7X12. These are the unit cost. These are the actual quantities that were shipped. Okay, so you need to do some product equals products, open a bracket, don't close yet, and come inside the unit cost, select all of it, you stop there. You don't come down here, okay? No, you just stop here. These are the unit cost. Okay, then comma, don't put semicolon and just put comma. Remember, Excel has a special formula and special requirement and special syntax to solve it. Comma, then release your hand from the cell and come inside the orange cell and start from the first one. Pick all of them. Okay, and close the bracket. You see that? That is going to compute some product and enter. Yeah. So I have properly translated this. I've properly translated that problem into Excel. Yes. The next thing is now to call the solver and tell the solver my constraints, my objective functions, and my decision variables. So you are going to come here, add-ins, call the solver. Okay, call solver, come on quick, come on quick. Okay, it's coming up. Yeah, okay, cool. So I was solving some problem before, so let me delete. This is the solver. Let me delete this. It's what is happening today. It's super slow. Okay. So let me delete this. And let me delete all the previous works. Yeah, I just have to wait. I can't do it one at a time. I mean, all at once. I have to do it one at a time. I have two more left. And the last one is that. Now, I've called the solver. The solver doesn't know. Now, I need to tell this solver the objective function and the constraints and the decision variables. Okay. Firstly, I'm going to add objective function. Add. You see that? Let me move it up. So this is the objective function. I'll click the green cell, and that is exactly I-19. Okay. And I'm minimizing. So I'll pick minimize. So objective function. Okay. That is done. The next thing is to tell my solver the decision variables. So I'll pick normal, add. So what are the decision variables? All the x1 to x34, x11 to x34. So decision variables. Decision variables. Okay. Which are x11, x12, x13, x14, x21, x22, x23, x24, x31, x32, x33, x34. These are decision variables. And what I've just done now is just a comment. You can type in anything you want here, like a description to explain what you are doing. But inside here, you have to pick all these cells. See that? Pick all these cells, pick them. So all these 12 cells, you can see D13 to G15. Those are the cell reference or for our decision variables. Click OK. So I'm done for the variables. Then the next thing is the constraint, after which I can now solve the problem. Okay, so here I have I'll pick constraint normal, and I will add a constraint. Let me move up. Remember, we have a 12 constraint. If you look down here, you have a subject to x11 plus x12 plus x13 plus x14 equals to 5. That is the first row constraint. Under the orange cells, you make sure the addition of the first row must be equals to the first blue cell here. Okay, so I have you must make sure the what you have added in the first row must not exceed the supply capacity for source number one. So you will do this. This I13 must be equals to click constraints sum row 1. See that? Add it again. This second cell here, the supply capacity for the source number 2, S2, must be equals to the click constraint here, second blue cell. You see that? Again, click add. One more time, you make sure the source number 3 capacity, which is 3, must be exactly equals to the third blue cell. Okay, so that is all the row constraint, row 1, row 2, row 3 constraint. Now let's add more. for the column constraint. You must make sure your what you have in what you have in demand here, the cell, these three must be equals to this. So these two cells must be equal. So you can come here and have this number 3, this cell must be equals to constraint number 1. That means when you solve this problem, whatever you have under the D1 column must match up with number 3. Remember, the D1 column represents the demand by the first destination. It must be exactly 3. And you remember that the yellow cell is actually the sum of the first column here. The second yellow cell is the sum of the 3 orange cells under D2 up until your D4. So D17, that is you can call that you can call that constraint, column constraints, column constraint 1. Okay, let's add more. Okay, the reference cell is what? This yellow cell, okay, must be equals to this number 3. You can call that column constraint 2, or column 2 constraint, sorry, column 2 constraint. Excuse me. So hard more because we have four columns. So that is that. Then again, this third yellow cell must be what? Equals to constraint 2. So that is a column 3 constraints. Okay. In the last one, you have a come on quick. You have a where is mouse? I hate this. Okay, cool. And the last one, you have a fourth yellow cell must be equals to, click that constraint, must be equals to 2. That is column 4 constraints. Okay, I have I'm done for all the constraints. You see that? Now, the step is this: you must make sure you translate the problem into a solvable form in Excel. After that, you call the solver and you set up the objective functions, the decision variables, and the row constraint and column constraint. Now, you have to make sure you click non-negative, you make this non-negative. And you can pick, there are several options here, but I will pick standard linear programming solver. Okay, if I solve that now, before solving it, I want you guys to observe that there is nothing inside the orange cells. I'm looking for 12 numbers to fill the orange cells, but I cannot fill them automatically. I could have put anything there initially if I want, but I don't have to do that. So the Excel assumes 0 for all of them. But when I solve it now, you just keep your eye watch on the yellow cell, orange cells, the yellow cell, the blue cells, and the green cells. Excel will give you a nice solution. I'm sure it's going to work. Perfect. Great and very, very fantastic. You see that? Now, look at D1. You have 300. D2, you have 003. D3 you have 020, D4 you have 200. And when you see the yellow cell, automatically you have 3322, which match up with demand. So after solving it, the total column, the total number of the, the sum of D1 columns must match demand 3. Sum of D2 column must match demand 3. Sum of D3 must match 2. Sum of D4 must match 2. And when you look at S1, all the rows 2, you see the supply column and the sum rows 5, 2, 5. So those numbers must match. So now we have been able to look for X11, X12, X13, X14, X21, X22, X23, X24, up until X34. So my X11 is now 3, X12 is 0, X13 is 0, X14 is 0. You continue all that up until X34, which is also 0. So you can keep the solution, or you can look at the answers here and check. You see the answers? So you have a report. You have a report down here, answer report. You see down here, you have let me take this up. You have the solution to be here. Initially, you have 0. You see that? Initially, the orange cells were all zeros. You see? You didn't see them, all these zeros there. But at the background, Microsoft Excel have assumed a value of 0 for each of them. And the final solution for X11, X12 to X34 is this, what you have here. Okay? And you can sheet. You can also generate sensitivity reports for it. So if you want, okay, but I don't have to do that. So that is how you can use Microsoft Excel to solve a transportation problem. You see, if I show you Lingo, uh, you see, you can translate the same problem into another software called Lingo. Okay, and this is how you want to set it up. And if you solve this, it's going to give you the same thing. You see this 32? You see all the numbers here? You see the X11, you see everything? So that's it. I hope this is very, very informative for anyone that is planning to use a Microsoft Excel for solving a transportation problem or any other similar optimization problem.